All right. Hello, Algebra 1 students. It's like 8:45, and I've now received a couple emails, concerns about one of the two IXL topics we were working on today, about graphing quadratic equations from standard form. It should generally follow from the lesson 9.2 Edpuzzle video you watched on Wednesday. But for those of you that are confused, I'm just going to go through one here real quick, how I would do it, a couple of different ways that it can work for you. So I'm going to share my screen so you can see that IXL topic and an example, and I will go through that with you. So here is, hopefully you can see this tab. This is the IXL topic. We're talking about graph quadratic functions in standard form. Here's an example for you. Graph the function f of x equals x squared minus 10x plus 15. So they want us to graph that quadratic equation. Remember, we've moved from quadratic expressions, quadratic trinomial expressions that we were factoring in chapter 8. We're now graphing them as xy functions in the coordinate plane. So this underneath that equation, the directions sort of give you the two steps that we need. Number one is plot the vertex. And to plot the vertex, we need to find the coordinates of the vertex. And as a reminder, the coordinates, the x coordinate of the vertex is going to follow the formula x equals negative b value divided by 2 times the a value. Okay. So that is going to be our x coordinate of our vertex. And again, as a reminder, the a value is the number in front of x squared, which in this case is a 1. The b value is what's in front of x, which in this case is a negative 10. And the c value at the end is plus 15, which we don't actually need for this formula. So the x coordinate of the vertex for this particular graph is going to be negative 10 divided by 2 times 1. Okay, now I apologize for my penmanship. I'm trying to do this on a mouse pad, so you have to forgive me on that. The top of the fraction here of my formula, negative b, has a negative in front of a negative 10. So a negative 10 is going to flip to positive 10. And on the bottom, 2 times 1 is 2, which means this all equals 5. Okay. So the x coordinate of the vertex is going to be 5. All right. So if I were to go back to my IXL topic, if I go to the origin, you see how they give me this fun little dashed line circle here. If I slide that over on the x-axis to 5, this is sort of where I'm going to put my vertex, is at the x coordinate of 5. Okay, somewhere around here. We also need to know the y coordinate, though, of the vertex. So to do that, we have to plug the 5 into the equation. Okay, and in this particular case, that equation is then going to say 5 squared, right, 5 to the second power, minus 10 times 5, because we're replacing the x again with a 5, and then plus 15. So that is going to equal 25 minus 50 plus 15, which if you do that math, negative 25 plus 15 is going to equal negative 10. Okay, so negative 10 is my y coordinate of the vertex, which means overall my vertex is 5, negative 10. All right, so that coordinate point is going to be where I plot my vertex. So I follow this formula, x equals negative b over 2a. Okay, this guy over here. And then I find my y coordinate by plugging that x value into the equation. And I get a vertex of 5, negative 10. 5, negative 10. So I can plot that down there. I just go to that point and just click. Okay, so now you can see I've plotted a vertex. And if I go somewhere else on the graph, it will graph a parabola for me. It's actually quite nice. All I need to find is one other point. Okay, just one other point. Now, there are 2 ways to do that. Number one, if you can use the y-intercept at the end, that's kind of an IXL shortcut, is you can just plot the y-intercept, which is the C value of the equation. So if the equation ends plus 15, just go to plus 15 on the y-axis and click, and you'll be done. Okay, so if you were to click, there you go. I've made my parabola. Now, obviously, I'm not going to hit enter here because this is wrong, but you could click a second point on the y-axis and you'd be done, hit enter, submit, move on. Okay, now, if you need to undo it, as it says, you can click the second point and then you can move it around, right? So I can't use the y-intercept in this case because 15 is not on the graph. I can't get there. 10, 11, 12, 13, 14, 15. So the other option, which we talked about in the video, was what we call overs and ups. So overs and ups is kind of, my fancy way of talking about the change in the y and the change in the x of our equation here. So normally the overs are going to be 1, 2, and 3. You can put 4 if you want. Okay, so those can be the overs. And then the ups column in a normal quadratic equation is 1, 4, 9, 16. Just as a reminder, the reason that it goes 1, 4, 9, 16 is because those are the squared numbers. And remember, the first part of the equation says x squared. So the overs are 1, 2, 3, and 4. The ups are 1, 4, 9, and 16. But the ups get multiplied by the a value. Okay, the ups are multiplied by the a value. Just the ups. Okay, so just these ups numbers here. Okay, 1, 4, 9, and 16 get multiplied by the a value. In this case, the a value is 1, so multiplying those numbers by 1 is going to do nothing, which means if I, again, go back to my graph here, if I start at the vertex, remember overs and ups are from the vertex, not from 0, 0, from the vertex. So if I go to the vertex, if I go over 1 space, over to 6, and I go up 1, and I click, I'm done. Over 1, up 1. Why am I going up 1? Honestly, it's because of the a value. The a value is 1, which means over 1, up 1. Over 1, up 1. So I'm done. I plotted the vertex using my formula and plugging the x value in. Then I used my over and up idea. Going over 1, I'm supposed to go up 1. Multiplying it didn't change it here. So I will submit. Good work. Excellent. Okay, now let's look at this one. So this one, just one more quick example for you to see how this overs and ups thing works. I'm going to find the vertex again using my formula x equals negative b divided by 2 times a. Okay, and in this case, the b value is negative 20. So I have negative 20 divided by 2 times a, in this case, is 5. So if I do the math there, okay, so negative 20 is positive 20 divided by 2 times 5, which is 10. So my x coordinate is 2. All right. So I know that the vertex is going to be 2 comma something, right? So in terms of my graph, I'm going to be somewhere on x equals 2, right in this range. I'm going to find the y coordinate of the vertex by plugging 2 into the equation. So it's going to say 5 times 2 to the power of 2, right? 2 squared minus 20 times 2 plus 16. And 2 squared is 4. So 5 times 4 is 20 minus 20 times 2 is 40 plus 16. 20 minus 40 is negative 20 plus 16 is negative 4. So my vertex is 2 comma negative 4. Okay, 2 comma negative 4. So that's my vertex, and I'm going to plot it on my graph right now. 2 comma negative 4. Click. All right. Now I just need to find one other point. Can I use the y-intercept? No, because it says plus 16. So darn it, can't do that. So I can't plot plus 16 on the graph. So I'm going to have to use overs and ups again. So if I do that and I make sort of that little table one more time. Okay, and once you get used to this, you guys, you're not going to have to make the table every time. Okay, you should eventually sort of catch on that you don't need to do that. But again, overs typically are 1, 2, 3, 4, and ups are typically 1, 4, 9, 16. But remember, that the ups are going to get multiplied in this case by, what is my A value? Well, that's the number at the front of the equation multiplied by 5. So if I multiply them by 5, right, multiply these numbers by 5, the ups get multiplied by 5, which turns them into not 1, 4, 9, 16, but actually turns them now into 5, 20, 45, and 80, okay? So on this particular parabola, if I were to go over by, say, 2 spots, I would have to go up 20 on my y-axis, on my y-coordinate, because I went over 2 and I got to go up 20, because 2 squared is 4 and it gets multiplied by 5. Now, I'm not going to do that because I can't fit that in here, okay? I can't fit that, but I can fit going over 1 and up 5. Now, why am I going up 5? Because that is the A value in the equation. It says 5x squared. So go over 1 from the vertex, over 1 square, and up 1, 2, 3, 4, 5 squares. So it's a real skinny one, right? Okay, real skinny. So this is the parabola. It's finished. That's all I need. It did the whole rest of it for me. I don't have to plot any other points. I can just scroll down and hit submit. Okay. So hopefully this helps you sort of navigate the IXL piece here. Click the vertex, which you have to do some work to find. Okay. And then, move forward from there. Find the coordinates of the vertex, use your overs and ups, or if you have a situation like this, plus 10 on the C value, I can just plot the y-intercept. Either one is fine. Now, I know this seems like a lot of work, but let's understand. I just did 2 problems. My SMART score is 36, right? You have to get to 80. You're gonna be looking at doing 5 of these, okay? We can do it. I believe in you. I trust you. And I will talk to you all about it on next week if we struggle with it, okay? I may send out an email, try to hook up with you guys on Zoom on Monday or something like that. But hopefully this helped. If you need anything else, send me an email. I'm here for you. Talk to you later. Have a spectacular night.